let us understand about primitive polynomial. So its first feature is that it is used to construct the extension field from the base field. Second is that it is a prime polynomial over base field. Prime means it has no roots in the base field. As well, it is monic. Monic means its coefficient of its highest power is 1. So the first feature is that it is used to construct the extension field. How it is used, that we will see. Then second is that it has no roots in the base field, as well as it is monic. That means its highest powers coefficient is 1. Third is that if it has no root in the base field, then where it has its root. So it has root in the extension field. And which one is its root? That root is the primitive element of the extension field. So the primitive element of the extension field is the root of primitive polynomial. So let us once again see that primitive polynomial is used to construct the extension field from the base field. Then it has no root in the base field, as well as it is monic. Then third is, if it has no root in base field, it has root in the extension field. Which is that root? That root is the primitive element of the extension field. So let us understand this. So let us take the primitive polynomial x cube plus x plus 1. So this is used to construct the extension field. Which extension field? So this x cube plus x plus 1 is a primitive polynomial over base field. Which is the base field? Is Galois field 2. That is its base field. So x cube plus x plus 1 is a primitive polynomial over base field, Galois field over base field 2, that is Galois field 2. So over Galois field 2, this x cube plus x plus 1 is a prime polynomial. That means it has no root in the Galois field 2. So let us see how. So x cube plus x plus 1 is prime or a primitive polynomial over base field 2. So Galois field 2 has elements 0 and 1. So 0 and 1 are the only elements in Galois field 2. But primitive polynomial, which is defined over Galois field 2, has no roots in Galois field 2. That means 0 and 1 are not the roots of x cube plus x plus 1. So let us put 0. So 0 plus 0 plus 1 is equal to 1. So 0 is not the root of x cube plus x plus 1. If it is root, then you will get 0 here if you put the 0 in this equation. So let us check about 1. So x cube, that is 1, plus 1, x is 1 plus 1. So 1 plus 1 means this is mod 2 operation, that is 1 plus 1 is 0, or XOR operation, or Galois field 2 operations. So 1 plus 1 is 0. So 0 plus 1 is 1. So 1 is also not the root of x cube plus x plus 1. So the primitive polynomial x cube plus x plus 1 is a prime polynomial because it has no roots in Galois field 2. Now it is monic because its highest power, what is the highest power of x cube plus x plus 1? X cube is the highest power. It has coefficient 1, so it is monic. So that's why this is a prime polynomial. If it is a prime polynomial, then we can use it to construct the extension field from the Galois field 2. So this primitive polynomial can be used to construct the extension field. So we are using it, so it is used to construct the extension field Galois field 2 raised to 3, that is Galois field 8. So till now what we have seen, that we have taken one base field, that is Galois field 2. There we have found one polynomial x cube plus x plus 1. Then we have checked that it has no roots in Galois field 2. Also its highest powers coefficient is 1. So it fulfills the criteria of prime polynomial. So it can be used as a primitive polynomial to construct the extension field from base field Galois field 2. So the extension field is Galois field 8. Now this Galois field 8, every Galois field has the primitive element So this Galois field 8 is also also having the primitive element. So that primitive element is the root of this primitive polynomial. So every field has a primitive element. So Galois field 8 has also primitive element. You know what is the primitive element, we have already discussed it. So let that primitive element is alpha. So that alpha is the root of this primitive polynomial. So alpha cube plus alpha plus 1 is equal to 0, because alpha is the root of the primitive polynomial. So what we have seen up till now, that we have first taken base field, that is Galois field 2. Then we have checked the one polynomial, which is x cube plus x plus 1, for its the condition of prime polynomial, whether it has roots in Galois field 2. So we have come to the conclusion that x cube plus x plus 1 has no roots in Galois field 2. Also, it is monic. So we have used this polynomial to construct Galois field 8, that is extension field 2 raised to 3 from base field Galois field 2. So Galois field 8 has the primitive element, because every field has the primitive element. Let that primitive element is alpha. So that alpha is the root of this primitive polynomial. So primitive polynomial has no root in the base field, but it has root in the extension field. So next we know that every non-zero element of Galois field 8 can be expressed as powers of alpha, because we know that primitive element is the one whose powers represent all the elements of the Galois field. So if alpha is the primitive element of the Galois field 8, then every element can be expressed as powers of alpha. So 0, alpha raised to 0, alpha 1, alpha square, alpha cube, alpha 4, 5, 6. So these are total 8 elements. These are total 8 elements can be represented as powers of alpha. Now this alpha is the root of primitive polynomial. So we know that primitive polynomial is x cube plus x plus 1. So alpha x cube plus x plus 1, that is alpha cube plus alpha plus 1. So alpha cube we get it as alpha plus 1, because alpha cube is equal to minus alpha minus 1. So minus is not there, so instead of minus we write it plus in mod 2 operations. So alpha cube is equal to alpha plus 1. So these elements from alpha cube we can represent in terms of these equations, that is alpha cube is equal to alpha plus 1. So 0, alpha raised to 0, alpha raised to 1, alpha square, then alpha cube we can replace it with alpha plus 1, which is called mod of primitive polynomial. We are representing the elements in terms of mod of primitive polynomial. Why mod? If you divide alpha cube by alpha cube plus alpha plus 1, the remainder you will get as alpha plus 1. So we can say it as a mod of alpha, mod of primitive polynomial. That we will see in next video in detail. Right now you have to just understand that we are representing in terms of primitive polynomial equation, because alpha we are putting alpha as a root of primitive polynomial and we are getting this equation. So we are representing alpha cube as alpha plus 1, alpha raised to 4 as alpha into alpha cube, that is alpha into alpha plus 1, alpha raised to 5 means alpha into alpha raised to 4, that is alpha into alpha alpha plus 1, alpha 6 is alpha into alpha 5, that is alpha 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 plus 1. We are not solving this because that is not the intention of this video. So here just we have to say that every element is represented as powers of alpha, as well as they are represented as powers of alpha taken modulo primitive polynomial. This is called modulo primitive polynomial, mod of px. So this is all about the primitive polynomial. In short, let us revise it. That primitive polynomial is the prime polynomial over base field. So primitive polynomial is a prime polynomial over base field, and it has no root in the base field, but it has root in the extension field. It is used to construct the extension field. It has no root in the base field, root in the extension field, and that root is a primitive element of extension field. So every element of the extension field can be expressed as powers of primitive element as well as mod of primitive polynomial, can be expressed as powers of alpha or the mod of primitive polynomial. So this is all about the features of primitive polynomial.